potatoes of our trig study is that cheat sheet. And so I'll put mine at the top here, my unit circle. Am I frozen for you guys here in class? Yes, I am. All right. So I know that for the unit circle, I've got these points right here. 1, 0, 0, 1, -1, 0, and 0, -1. And then I know for an arbitrary point on the unit circle, there's the adjacent side is x, the hypotenuse is, or excuse me, the opposite side is y. Hypotenuse is 1. That's for my arbitrary point x, y. So that now I can say, hey, cosine of my angle, I'll put my angle right there. Cosine of my angle equals the adjacent over the hypotenuse, which is x over 1, or just the x coordinate. Sine, similarly, is the opposite over hypotenuse, which is the y coordinate. And then tangent, as we've discussed recently, is y over x. That's got to be in your cheat sheet, or on your cheat sheet. That's got to be like in your brain, dead right, so that when I see a quadrantal angle on number 2 or number 3, automatically I'm thinking, boom, right there, unit circle. Now, on number 1, Christian, can you help me convert, since I'm a degree man, convert 7 pi over 6 into degrees? Good. And he explained that like a boss. If you didn't catch that, then once again, go back through your notes where we talk about the conversion rate. We talked about stoichiometry in your chemistry class and all of that fun stuff. Where you're multiplying by 180 over pi, the pi's cancel out. 180 divided 6 by 30. 30 times 7 is 210. Now, 210, Michael Davis, is in which quadrant? And Stephen Wiggs, what is your reference angle in that third quadrant for this angle? Good. If you're wondering where the dump 30 degrees came from, remember, 210 is how far away from the nearest x-axis? 30 degrees. So if we're cutting an angle past 180, we're going to say, oh, well, how far past 180 did I go? That's that 30-degree angle right there. Now, Franklin, I need your help to label the sides of this triangle, given that it's a 30, 60, 90. What kind of one? It's negative because you went where? Good. And then, very nice. Okay, good. And I love a couple things. Number 1, he knew directionality. If I'm going down, it's negative. If I'm going left, it's negative. Number 2, he knew exactly where to go in his notes to find that 30, 60, 90-degree triangle. Ideally, we have it what? Memorized, and that comes through practice, 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 practice. Okay, so Kenneth, help me out. Cosecant is blank over blank. This is SOHCAHTOA.
Oh. So, 1 over some.
Give me words like adjacent or opposite or hypotenuse.
Oh. That'd be hypotenuse over opposite.
Excellent. I love how your brain's working. Did y'all catch what he said or thought first? That's exactly right. And that's what you need to do. He thought cosecant is the reciprocal of sine. Sine is the opposite over hypotenuse. So this will be hypotenuse over opposite, aka -2. Now, is there a cosecant button on my calculator? There is not. What if I wanted to use my calculator to check that answer? I would do 1 over the sine of 7 pi over 6. What mode would I need to be in? If I said 7 pi over 6, I would need to be in radians mode. Or I would just need to put the little r up there. What is this? Check for notifications. Close. Put that over there. Yes, sir.
Would secant the same variable be the secant of 210? Would that be like 2's on the clock, 2/3?
See, if that was secant, it would be 2 over negative radical 3, and we would rationalize. And by the way, did y'all had on your delta math, y'all had all 6 trig functions you were having to work with? It's really good to rep that out more than just what I assigned, right? I'm in degree mode, so I'm gonna go ahead and type 210, and I'm gonna get my -2 as my answer there. Okay, Andrew? Yes, okay, so pause just for a second on the warm-up, and let's discuss here. This is positive, negative, positive, negative, right? So anytime I draw a triangle in the first quadrant, I went to the right, so I know that's a plus. I went up, so I know that's a plus. By the way, the hypotenuse is always positive. Good. Now, if we go over into the second quadrant, because I went to the left, that's negative, but I'll go up, that's positive, and the hypotenuse is always positive. Down here, again, negative. This time it's negative because I went down. Hypotenuse is always positive. And then over here, I got negative, I got positive, and I got positive. So that's kind of an explanation of when I move to the left, the adjacent side is negative. When I move down, the opposite sides are negative. And then ASTC is my like fail-safe mnemonic there, ASTC. So I know that in the third quadrant, only tangent and cotangent are positive in that way. But because that's opposite over adjacent, negative over negative. Now, 3 pi over 2, Jack, is how many degrees? Beautiful. So the tangent of 270 gets me down right here, and I know the tangent is y over x, so that's negative 1 over 0. How do y'all feel about that? Undefined. Okay, and then secant, oh, good grief, I'm doing this on the wrong page. Oh, well. Secant is similarly, it's going to be 1 over the cosine of pi. Now, pi is, BJ, do you know how many degrees pi is? Let's see here, Henry. 180. So I'm going to get my eyes over here at 180. And I think, all right, cosine is the x-coordinate. X-coordinate's negative 1. So it's 1 over negative 1 or just negative 1 right there. Okay. All right, so tangent of 270. Down here at 270 is quadrantal angle, so we use our unit circle. And tangent is the opposite over the adjacent. So in the red triangle, that would be y over x. And then down here, the y coordinate over the x coordinate is negative 1 over 0. Negative 1 over 0 is undefined. Good question, Blake. Anybody else on those 3 warm-up questions? Bless you. All right, fellas, this is what it takes to be successful in your math class. You've got to have basic facts memorized, and you got practice, practice, practice. And today we're going to get some more practice in. Definitely going to get some more practice in. Let me see if I can do this. I'm going to. Yes, sir.
That's just which of the 3 were quadrantal angles, and what do you mean by that?
All right, so quadrantal means that I've got a terminal side in standard position that falls on the falls between quadrants. Okay, and so let's take a peek real quick at our quadrantal angles. We would have 90 degrees, 180, 270, and 360, and also 0. These are called quadrantal angles. And anytime I'm trying to evaluate a trig function of 90 or 180 or 270 or 360, I need to draw out my unit circle and think cosines x, sines y, tangents y over x.
What are the 90?
So pi over 2, pi, 3 pi over 2, and 2 pi. Those are the equivalencies there. And I like how oh, good grief, my brain stopped working. He did a really good job of it. Whoever it was that was converting explained how to convert by multiplying by either 180 over pi or pi over 180. And BJ, that's something you missed last week that would help when we're converting from degrees to radians. When you're going from degrees to radians, you multiply by pi over 180. And when you're converting from radians to degrees, you're going to multiply by 180 over pi. Those are our 2 conversion factors. Definitely want to write that down. Finley, you good now?
Yeah.
All right. So here's what we're going to do. We're going to talk a little bit more about these reciprocal trig functions. Okay. Just to give you, like I said, it's a little bit more of some reps. I've got cosecant of 5 pi over 3. Okay. Walk me through, Nash, can you help me with where's 5 pi over 3? In which quadrant? Very good. It is the 4th quadrant. The degree equivalent will be 300. And so what would be, Aiden, what would be your reference angle for 300 degrees? Excellent, Aiden, excellent. Now that helps me because now I know the opposite side's negative radical 3, the hypotenuse is 2, the adjacent's 1. That's from our 30, 60, 90 that Franklin mentioned a minute ago. And then Freddie, what's cosecant? Blank over blank. Beautiful. I love how Freddie's paying attention. He's locked in. That's good. Phil, can you help us rationalize that fraction now? All right, beautiful. So I got 2 square root of 3 over 3. I always like to put my negative up top or out front. There we go. Easy enough. Kenneth.
Would it matter if I would have multiplied negative square on top of mine?
No, it wouldn't matter at all. All right, we've looked at cotangent already. Okay, this was our last one. This one's a little bit weird, and I thought I hit you guys up with this. Michael Esten, what is the point of an inverse trig function? What does it help you find? We're going to use those a lot today in our class. And what do we normally, Nicholas, what do we normally take the sine or cosine or tangent of? An angle. So fellas, I want you to treat, based on what those two guys said, I want you to treat this highlighted green expression like an angle, okay? Figure out that angle first, okay? Now, it would be very easy for me on my calculator to do that, so I'll show you there. And then let's say my calculator poops out, and I need to know how to do it by hand. It's not going to be bad to do it by hand at all either. I am in degree mode, so that's fine. I'm going to hit second cosine, and then we'll just do radical 3, get out of the radical, divide by 2, and I get 30 degrees, okay? So this is saying, hey, in essence, we want to know what is the cosecant of 30 degrees, all right? Now, I put something interesting, and the jacket's coming off now because it's about to get real up in here, okay? I put something in parentheses that says, remember the principal value range for cosine, okay? Remember the principal value range for cosine. What are you doing here?
Kenneth, I think. Kenneth threw it. He tried to give it a little bit. Watch it play out.
Well, you know what? That's okay. I'll take care of it. I'll take care of it. Read it.
That's the drawing.
Oh,
The drawing. This one. It's a deep drawing.
Is that what?
the game that we played for Logan.
Okay. All right. Here's what I want to teach you guys at the start of today's class. This is very, 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 very important to lock in about with our inverse trig functions. Okay. Andrew.
I'm not the math. It's something different.
That's what I'm about to explain. Okay, go ahead and tell me what you got, by the way. What mode are you in?
I'm in degree.
What mode should you be in? There you go. If you put it in degree mode and rerun it, that's all good. If you get it in degree mode, you'll run it and get 30 degrees. But here's the rundown, okay? So when we have our inverse trig functions, okay, so like arc, sine, arc, cosine, and arc, tangent. Each of these has a what's called a principal value range, okay? Where our calculator, for instance, is pre-programmed to only give you an answer that falls between these different angles. So, for example, with arc cosine, it goes from 0 to 180 or 0 to pi. Okay, it goes from 0 to 180 or 0 to pi. For arc sine and arc tangent, it goes from negative 90 to positive 90. In other words, the calculator is only going to give me, it's here, negative pi over 2 to positive pi over 2. Calculator is only going to give me answers that fit in that range. Okay, it's pre-programmed to do that because you might remember with when we were working on finding inverses I'll do this on the sideboard over here, right? What, Michael Davis, what's the, if I give you f of x equals x squared, and I said, hey, Michael, what's the inverse of that? You remember how we have two steps? You switch x, y, solve the new y? Okay, so what's the inverse of x squared? Walk me through that process. Let's do a little exam review for us. That's right. So I'm gonna write it up. I got y equals x squared. Switch x and y. When you see a y, put an x. When you see x, put a y. Go ahead and read what you want me to put.
X.
Beautiful. And then I want to get y by itself. That's your second step. So what would you do? Beautiful. So y equals square root of x. And so that's our inverse function. We'll come over here and we'll say square root of x. But you guys know that the graph of y equals x squared is what? A parabola. And the graph of y equals the square root of x is
Half of a parabola.
half of a parabola. So are these symmetrical about the line y equals x?
No.
No. That means that we need to restrict, chop off half the parabola for our first function. There is a domain restriction that must be employed here because there's a domain and range restriction of the function. We've been over this. This should be a good review. The similar thing is happening with our sine, and cosine, and tangent functions. Okay, I'm going to let a cat out of the bag here. That the sine function, y equals the sine of x, it looks like this. It's a wave function that goes infinitely, just back and forth, oscillating back and forth, back and forth. Is that function one-to-one and therefore invertible? No. It fails the which test? Good. It fails the horizontal line test. And so mathematicians, they said, hey, you know what we've got to do? We've got to cut this off, making it one-to-one. Therefore, we are restricting its domain from negative 90 to positive 90. That's what they're doing. By restricting the domain of the function, you are restricting the range of the inverse function. Okay, so what I'm telling you all that because the calculators you use are pre-programmed to only give you an answer when you employ the arc sine function, only give you an answer between negative 90 and positive 90 degrees. But there might be more than one answer. Like at this point, I'm bored, by the way, because I know what cosecant of 30 is. Okay, I draw my 30-degree angle, 1, 2, radical 3. So it's going to be 2 over 1 and easy money. Okay, but the point is, it won't always just be 30 degrees is my only number. Okay, can I do this? I think I need to copy these. I don't think, yeah, I definitely need to copy these. Copy, paste, 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 delete, delete, delete. And there we go. All right, so what I mean by that is, on your calculator, I want you to run the inverse cosine of 0.5437. Just tell me what you get. Yeah, about 57 and some change, right? About 57 degrees. What about inverse tangent? Come on, quick fingers, quick thumbs. I know I've seen y'all text before. Negative 72? Well, I'm getting some disagreements here. Can y'all figure it out? Reconcile your difference? All right, that's fine. And then how about my last one here? Remember, this one's tough because it's cosecant. You got to do 1 over arc sine. You got to do 1 over arc sine. And what happens? Did you get, Mike, would you get something? Yeah, it didn't work. You got an error message. So you got to put a big fat question mark up on this one. You guys say, okay. Because if I do 1 over sine of this, I'm not allowed, 1 over arc sine of this, I'm not allowed to come up with an input that is more than 1 or less than negative 1 for sine. It doesn't work that way. Okay, but let's pause just for a sec and see if we can go back to my question in red here of, okay, what else? If I've been given in the instructions that I'm supposed to find all of the angles from 0 to 360 that produce this value right here. Okay. And I say the question, what else? I need to remember that for every trig function, there are 2 quadrants in which it is positive and 2 quadrants in which it is negative, right? So 0.5437, for example, 0.5437 could be the opposite in 2 different locations. What the calculator helps you find is the RA. I like angle. What kind of angle? Not reciprocal. Not right angle. Reference angle. It tells me that, hey, 57 degrees works right here, but where else does it work? 57 degrees works right there. So now I've got not only one answer, but I've got another answer. What would that second answer be, given that it's got a reference angle of 57? Where is your nearest x-axis? And have we 57 is a reference angle, and I'm looking to see, well, what is this angle in standard position? In other words, what is this bold? You said it's what? 120. How'd you get that? You did 180 minus 57. So there would be 2 such answers. So we'd say 57 degrees, or would you say 123? 123 degrees. And you could test that out on your calculator. You could punch in, you could say, hey, what's the cosine? I'm in degree mode, right? Of 123, and we get 0.54. Oh shoot, why did I do it in the second quadrant? Y'all supposed to yell at me when I make careless errors. Is cosine going to be, I was looking at it like it was sine. Is cosine going to be positive in the second quadrant? Oh, tisk tisk, shame on me. Where else is cosine positive? It's going to change your answer. Fourth quadrant. All right, so 57 degrees. Let's poo-poo on that 123 and say, all right, if 57 is my reference angle in the fourth quadrant, right? And 0.5437 is my adjacent side. Yeah. So it'd be 303 degrees. We go all the way around to 303 degrees. So now I'm gonna go back. And by the way, that's a good argument for why we should be checking our work on the calculator, just to make sure it makes sense. So if I hit cosine of 57, I get that 0.5437-ish. All right. If I hit cosine of 303, again, I get that same value. There's 2 spots where the inverse cosine is going to be applying right here. All right. Let's, what do I want to do? Doobie-doop-doop-doo. We'll get there eventually. How about inverse tangent? What'd y'all get? You said about 72? All right, so that's the first quadrant. Where else is, it shouldn't be the answer. Because y'all told me, did you tell me negative 72? Okay, good. Because tangent, if it was positive 72, that's in the first quadrant. And tangent is positive in the first quadrant. This being a negative number, I know it's going to be in the fourth quadrant, but where else?
Second.
It's going to be second quadrant, right? Because think about ASTC. ASTC. Tangent is positive in the first quadrant, it's positive in the third quadrant, it's negative here, and it's negative there. So what would my other angle be? We've already seen the second quadrant when we said 180. Louder, Eli? Minus. So we do 180 minus 72, which would be 108. Or 108. Nash, can you hold that just for a second? 108. Hey, let me ask you guys this. Do either of those, or actually, Phil, let me hit you up. One of those answers is improper. One of those answers is wrong based on what's highlighted. Which one do you not like? Read what's highlighted. We want our angle to be between what and what? Very good. And which of these two is not that?
Oh, negative.
Yeah, boo bad. So can you think of a C word that helps me find, louder, coterminal? How do I get a coterminal angle? Add 360. What's 360 plus 72? Plus negative 72? So 298. And again, we could test our workout. We could say, hey, what's the tangent of 298? And we're rounding things, but we do end up, no. Would you, 288. I can't hear. Teddy yesterday was busting my chops. He's like, Dad, you can't hear anything anymore. And I'm like, what is that supposed to mean? He's like, you're getting old, Dad. We were in the car. So I couldn't make him go to his room.
Side of the road.
But he's very sunburnt because he, like an idiot, all day long Saturdays, didn't have a shirt on. And he was Boy Scout camping all day, so they were outside. And so I should just give him a little slap on the back. That's what I should do. Say, oh, son, here we go. All right, can we talk about number or part C here? Okay, let's talk about this. What do we use, Freddie, are you listening? What do we use inverse trig functions to find? Angles. Good, Mitchell. We always use inverse trig functions to find an angle. So since our calculator pooped out, Michael was right when he said, hey, it gives you an error message. We're going to say pretend like this equals some angle. We'll call it alpha. Okay. I'm going to draw a picture. Jack, you with me? We'll draw a picture. Okay. Now, where is cosine's principal value range? Y'all saw that maybe about 10 minutes ago. Between what and what? Good. So I know that alpha is going to be an angle somewhere between 0 and 180. Now, each principal value range is going to include a quadrant in which your function is positive and a quadrant in which your function is negative. And since 0.301 is positive, I know this is going to be a first quadrant angle. Now, again, I screwed the pooch by talking about cosine. This is cosecant. So his reciprocal is sine, and it's from negative 90 to positive 90, fourth quadrant or first quadrant. But since this is positive, it's still going to be in the first quadrant. Let me draw up a picture of what alpha looks like. Okay. Now, this is cosecant. So cosecant is blank over blank. Think SOHCAHTOA. All right, very good. So I've got 3.0156 hypotenuse over opposite. There's my picture. Okay. So how could I figure out, since the calculator doesn't have a cosecant button, it certainly doesn't have an arc cosecant button, how could I figure out what alpha is, given that this picture now is fully labeled? What could you do? Well, my choices are second sine, second cosine, second tangent. In other words, arc sine, arc cosine, arc tangent. Which one would be appropriate for cosecant? Arc sine. And arc sine of what? 1/3. Good. So I'm going to pull up, I'm going to say arc cosine or inverse cosine. I keep saying inverse cosine. Inverse sine, pardon me, of 1/3.0156. And that's going to give me my RA. That's going to give me my what? My referencing. All right, so let's do that. And I hope you guys are following along on these calculator operations. We're going to do sine, inverse sine, excuse me, of 1/3.0156. And we'll get about 19.4 degrees. We'll say 19.4 degrees. Okay, so where else does sine have a positive output of 3.0156? It does. Where else? Remember, sine is positive in two quadrants and it's negative in two quadrants. Very good. ASTC. So we've got our angle right here, and now we want to figure out the angle over there. Okay, so if my reference angle is 19.4, what would the other value be? 180 minus 19.4, which would be 160.6. All right. And like we were talking about, I forget, I think Phil maybe is the one I asked about. We're supposed to find all the angles between 0 and 360 that fit that bill. And this one is, I mean, this one really is a challenging example because you have to think, how do I use the calculator when there's not a cosecant button and there's not an inverse cosecant button? Okay. And what helped us in red there? Drawing a diagram, drawing a picture. Okay. By the way, the units, I don't know if you read this note, but the units are supposed to be in terms of degrees because that's what the interval was given us in terms of. All right. So now we're about to look at one in terms of radians. Okay. Let's try out, let's just do part A. So the secant equals 2.1647. Where is secant going to be positive? Try again. 4 and 1. And which one is the calculator going to give me? Well, it's only going to give me one because the principal value range for cosine is from 0 to 180. So here's where my reference angle is going to be. Okay. Because secant, I don't have an inverse secant button. I need to think about secant is hypotenuse over adjacent. And so we're going to do 2.1647, make the adjacent side 1. And now I can use my inverse cosine button. I could say inverse cosine of adjacent over. And it's only going to give me one angle, 62.5. 62.5. I did adjacent over hypotenuse. Now, if you are a shortcut person, I got several of y'all in here that are good with shortcuts. If you're a shortcut person, here's what you could just remember. When you're using inverse trig functions and you have to involve these reciprocals, then you could just do 1 over the number that they're giving. Inverse cosine of 1 over 2.1647. Here, we don't have to mess with it because it's sine. That's cake. And then here we would do inverse tangent of 1 over negative 1.5632. All right, where else did y'all tell me that cosine's positive? In which other quadrants? In the fourth quadrant. So I've got that angle. 62.5 degrees is my reference angle there. What's 360 minus 62.5? 297.5? Double check my arithmetic. I think it's 97.5 and 62.5. And then, Finley, what do we not like about those answers? Yeah, they're in degrees. How do I do a conversion? 5 over 180. Good. And that's where the calculator helps me out. 62.5 times pi over 180. No, you don't. Good question. 1.09. So we're going to say theta 1.09 or 297.5 times pi over 180, 5.19, 5.2. All right. Oops. So those would be our two answers for theta there. Do you see a problem with part B? Okay, so it's okay for a sine to be negative. We know we would be in the bottom two quadrants. But sine is blank over blank. Think SOHCAHTOA. Sine's blank over blank. Opposite of hypotenuse is, but by the fact that hypotenuse always has to be the longest side, it's restricted to being between what and what? 0. Between negative 1 and 1. Okay? That number is not between negative 1 and 1. So why would I bother wasting my time? I could throw on the brakes and say, yeah, no such angle works. Okay? Now, if you were to test that out, what would you do? You would do inverse sine of negative 1.0034, and you get an error message. So here we would say, no such solution. And then like we talked about a minute ago with cotangent, we would just say, hey, let's do inverse tangent of 1 over negative 1.5632. That's going to give me my reference angle. For tangent, that reference angle is going to be in the second quadrant. Okay. And then if, actually, this would probably be instructive to look at one where it gives you second quadrant answer. Has anybody already run that to get an answer? let's do that. Where are you, calculator? I'm going to do inverse tangent 1 over negative 1.5632. And we get negative 32.6. $32.6. It feels that way. It really does. I'm not exaggerating. All right, so 32.6. There are my two reference angles. Okay, help me figure out what the angles are in standard position. In second quadrant, we're going to say 180 minus. In the fourth quadrant, we're going to say what? 360 minus. And that might be instructive to also write that down. I don't know how you guys are with that. But if I've got reference angle in the first quadrant, it is what it is. If I've got a reference angle in the second quadrant, it's 180 minus that reference angle. Third quadrant, 180 plus that reference angle. Fourth quadrant, 360 minus that reference angle. Again, that's when you're in terms of degrees. So what's 360? 327.4. And what's 180 minus 32.6? 147.4. Double check my arithmetic. That gets you up to 150, 180. Yeah. Now, how do y'all feel about those two answers? So we would take the time to convert them into radians. I won't take that time now. Kenneth, question.
Yeah, one I put in inverse cosine 1 over 117.
Mm-hmm.
Sure.
That's in degrees. Multiply that by pi over 180, and it should get you one of these two, I think. And holler back at me if it doesn't. We'll troubleshoot.
And so you do, it just need 2.0.
All right, so let's go back. We said we're going to do inverse cosine of 1 over 2.1647. We'll get 62.4. Okay, no sweat. I've already erased that work, but 62.4 or 62.5 would be our reference angle, and that would take place in two spots. It'd be in the first quadrant, Kenneth, and in the fourth quadrant because of ASTC, first and fourth quadrant. All right, good question. So this is cotangent and tangent, and it's a negative number. And so cotangent and tangent are negative in these two quadrants. They're positive in these two quadrants. Negative in these. What's up? The confusion still? ASTC.
So would you do 1.7.4 times 5 and
Times pi over 180. Just doing that conversion. Yeah, if you get your answer in terms of degrees, just convert it easily by pi over 180. All right. Now we're going to set our calculators down, and this is where the rubber meets the road. Okay. We'll give you a step-by-step process for working such a problem. This step-by-step process works just as well with the ones that we've been looking at on the calculator so far. But you can save a little bit of time just by using the calculator instead of drawing it out by hand. But here's what we're going to do. We're going to follow an easy step-by-step process. I've got it handwritten on here already, but it's like I scanned a page of my notes. Okay. So we're going to look at sine of theta equals negative radical 3 over 2. Theta is supposed to be between 0 and 2 pi, so we're going to be in radians. All right, so here's going to be step 1. Step 1. Okay. Consider ASTC and figure out which quadrant you're going to be in. I know this example is different. It was in my old pencil paper note. But step 1, again, you can jot down your notes. ASTC and figure out which two quadrants you're in. Step 1, ASTC, figure out the quadrants. Okay. ASTC, figure out the quadrants. So for us, you tell me in which two quadrants is sine negative. Beautiful. All right. That's step 1. ASTC, figure out in which two quadrants you're at. this is kind of what we've been doing a little bit, but with the calculator, we were just focusing on the one answer. Here, we're jumping the gun and we're saying, hey, there's going to be two answers. Let's figure it out. All right, step number 2 is to label your picture using SOHCAHTOA. BJ, wake up. Label your picture using SOHCAHTOA. Now, Aiden, remind me SOHCAHTOA for sign, since we're just doing this first one. Sign is blank over blank. Beautiful. So this is my opposite, and this is my hypotenuse. And Michael Davis, which of those two is this negative supposed to apply to? Sure. If it was both, it would be negative over negative. We just can only do one. Good. It's going to be the numerator because hypotenuse is never negative. So we're going to label the opposite side with square root of 3, making it negative because we went which direction? And then the hypotenuse is 2. What is that, Blake? What does that make my other leg? Beautiful. Good job. Okay. Now here's the step 2, by the way, to label the triangle out. Jack, what is your reference now, given these two pictures? What's your referencing? It is. It's 60 degrees. Now that's nice because Blake labeled them and he labeled them based on our special triangles that we've learned, and Jack identified the reference angle, and so we have no need for the calculator. This is what the calculator was doing for us in the last 5 examples. The calculator was providing us with the reference angles. With these are a little bit easier because you had it memorized. You knew, oh snap, 30, 60, 90 because of the radical 3 and the 2 and the 1. Okay. Now, our next step of the process is to, based on these reference angles, right, figure out which angle and standard position we're dealing with. So, for example, here we go. With a reference angle of 60 degrees in the third quadrant, what would your angle be? 240. And with a reference angle of 60 degrees in the fourth quadrant, what would your answer be? 300. And then how do I feel about those two answers? What mode they should be in? Radians mode. And so here we would end up, I like to count. So I've got 6 pi over 6, 7 pi over 6, 8 pi over 6, or 4 pi over 3. Finley would tell us if you wanted to convert, you would multiply by what? Pi over 180. Here, this is going to be 5 pi over 3. Again, I don't have that memorized. I just count. I count around to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 10 pi over 3 is, or 10 pi over 6 is 5 pi over 3. So these would be our two answers for that example right there. Those are the two angles that produce, the two angles between 0 and 2 pi that produce an output ratio of negative radical 3 over 2 for the sine function. Okay, question. For which angle? 240 or 300? All right, so watch this. 240 times pi over 180. Now 60 goes into 240 4 times, and 60 goes into 183 times. So we got 4 pi over 3. That's you are doing like the Bereans did. You know who the Bereans were? New Testament scholars. What? Who went on missionary journeys? Paul. And who did Paul often take with him? Barnabas, known as the friend of encouragement. And what youngster did he take? Not Thomas. Starts with a T. Timothy. Good. And on one of those journeys, they went through this place called Berea, and he was teaching the gospel to them. And they went to the scriptures to test out Paul to see if what he was saying was true. And we, as New Testament Christians, are encouraged to do the same thing. Whenever anybody's preaching or teaching something to you, you got to test them out to make sure what they're saying is true. You know what I'm talking? It belongs right over there, fella. Go put it up. Anyway, so Blake, I applaud you. Test me and make sure what I'm saying is true, because guess what I make all the time? How dare you, Michael? No, I'm kidding. Yeah, I do make mistakes all the time. So testing it out, multiplying by pi over 180, very good idea. Thank you, Blake. Mario.
Pi over 180.
And the way I remember that is radians usually has pi in it. So put a little pi in it. If I'm going to degrees usually does not have pi in it. So I'm going to cancel out my pi. My pi goes on the bottom. Right? Now, I don't know if you guys feel as comfortable with your calculators as I do. But I'm going to show you how to solve this problem in a different way on the calculator. Are you ready for this?
No.
This is a different way to solve this equation on the calculator. You might like this way a little bit better. Okay. We're going to go to y equals. Everybody follow along with me, if you please. Go to y equals. And we're going to graph the sine function. We're just going to do y equals sine of x. Okay. And actually, since this problem was set up in radians, can we go ahead and change our mode to radians, please? Let's go mode, scroll down to radians. All right. And what I want to do is I want to show you a neat little zoom trick. Are you ready for this? Watch this. We're going to hit zoom. And which zoom do you think we might want to use here? Zoom 7 for zoom trig, because we're graphing a trig function. We're going to go to zoom 7. And what that does, it gives me a nice nifty window. Okay. I could probably clean that window up a little bit, given that the restrictions here are between 0 and 2 pi. But, you know, you don't have to. I'm going to go, my x min is 0, my x max is 2 pi. And then I can graph that out. And there we go. That's called one cycle or one period, one revolution of the sine function. Okay. And what we're called to do is we're called to see where does that equal negative radical 3 over 2. Okay. Now, if you look at y equals and you go to y2 and you just type in that numerical value of negative radical 3, get out of the radical, divide by 2. How many times does that red horizontal line hit my blue trigonometric curve? It hits it twice. Now, gee golly, I wonder in which two spots it hits it. It hits it at 4 pi over 3 and at 5 pi over 3. Now, this window is still kind of crummy. It's hard for me to see that. So I'm going to go from, instead of from 0, I'm going to go from pi. So I can see a little bit better. And my y, I'm not a big fan of the y. So let's go y minimum, maybe negative 3, and my y maximum 0. Just sort of setting a little bit of a better window. Make it negative 1. I don't like that either. Maybe negative 2. We'll centralize it. Yeah, there we go. I feel much better about that. Okay, so I'm looking for those two spots. Do we remember our syntax, Mario, for finding the point of intersection? Second trace. 5, enter, enter, enter. And it will find one of those values. Now, it's in radians mode, and so that's not so helpful. What do you think 5.2359878 is? 5 pi over 3. So if I'm a degree man, it probably would benefit me more so to have it in terms of degrees. But you could also just hit trace and type in the value 4 pi over 3, like to check your answer. And voila, we see it's that other point of intersection. So you could check your answers just by typing them in, hitting trace and 4 pi over 3, trace 5 pi over 3, and seeing if it's a point of intersection. Okay, Freddie, pick your head up. Let's do that for this second one. Okay, I'm gonna go to y equals. This one is, and I'm actually gonna try to move it at speed here. This one is positive radical 2 over 2. I'm just gonna hit zoom 7. And how many times does it hit my curve there? 2, 4, 6, hits it 6 times. Overall, how many times would it hit this function? Infinitely many, but I'm really only concerned with going from 0 to 2 pi, but I'm going to do 360. We'll do 0 to 360. I'm going to do it 90. And let's change our mode back into degree mode since I'm a degree man. And I'm going to hit graph. And how many times does it hit? It hits it twice. Mario, what was that syntax again? Enter, enter, enter. And 315 degrees. And where do you guess? Guess for me, because 315 is the weight room angle. Guess for me where the other one might be. Louder? 45 degrees. So right now, man alive, I've got the calculator helped me find this. So I told you I was going to do a little bit more at speed. I got pi over 4. Now let me count. 1 pi over 4, 2 pi over 3, pi over 4, pi over 4, 5 pi, 6, 7 pi over 4. 4, 7 pi over 4. I got my two answers. I got them lickety split using the calculator. Somebody mumbled. Oh, yeah. Oh, good. 3. Okay, Teddy, the middle schooler. I had 3 Boy Scouts in the back of my truck. Teddy was in the front of the truck, and 6, 7 was brought up. And I thought, my high schoolers have mentioned that before. And so the middle schoolers explained to me what they think it is. They were saying it's some rat guy. Weird from calling. What did they say? Is that accurate? Yeah. Big Hill Pond State Park. Oh, it's lovely. I love Big Hill Pond. I got down to about 37 at night, so they got cold because they were doing a survival camp out, and all they were allowed to bring was what they could fit in a bucket, a 5-gallon bucket. Well, 2 out of their 3-man team did. The third guy just brought a poncho liner, which is like a whoopee. You know what whoopee is? No, it's just for kicks and giggles. Tisk, tisk, tisk. Look at you dudes. Man, oh man. All right, I'm fixing to make you a new one for tonight. And this is homework. What section we in? 11.2. I think this is the third one we're doing. Did anybody beat my time of like 42 or whatever?
I got 42.
Oh.
I only tried to do it 6, 7.
Y'all are awesome.
Mine was pretty. His time was back great.
Mm-hmm. Y'all like the timed ones?
Oh, why was that? We did not.
Oh, yeah.
Okay, so arc cosine is going to give you an angle between 0 and 180. Radical 3/2, that's a positive number, so we're in the first quadrant. Adjacent to radical 3, so that means opposite to 1. That's 30 degrees. All right, now you probably, yeah, you're in degrees, so what's 30 times 2? 60 minus 100. 60 minus 100?
-40.
So I'm gonna think -40. If we did that on the fly.
Hey.
Yeah, there we go. Not too bad. You can do it. Let's see here. Oh, basic trig equations. That's what I wanted. Okay, there. And what's today? Let's make this do Friday. And y'all bring me some questions come Friday or come Wednesday. Oh, it's Easter. Yeah. Thank you. I always forget. I'll be having an egg hunt at my house. So we're gonna see you Wednesday, and then I'll see you again on Tuesday. So we'll make it the 22nd. Dude, we had like 900 eggs at the Morgan house last year.
That's why you are hiding them like in places only.